Okay, and so one thing you may have noticed is that the pH for this 0.1 molar HCl solution was 1. The pH plus the pOH came out to 14, and water, pH plus pOH came out to 14. And we're going to find out that it's always going to be true, where pH plus our pOH is going to be equal to 14. And the reason for that is because of our definition of Kw and the relationship between pH and pOH, and the definition of, and so how those logarithms work, it's going to come out that it's always going to be the case. So going back to this problem, instead of having to solve for OH minus concentration with Kw, taking the negative log of that to get the 13, we can just recognize that since our pH is 1, our pOH has to be 13 to make this come out to 14. Okay, so what about if we were going to go the other direction? Let's say we have a pH that we want to hit with a certain concentration of, say, HCl, to keep it simple here. So say we're trying to find something with a pH of 0.5. We want to know what concentration of HCl we need to get this pH. Okay, and we'll remember pH, which in this case is 0.5, was equal to the negative log concentration of H+. Okay, and so since we're talking about a strong acid, the HCl concentration and H+ concentration are exactly the same, so we just need to isolate this variable. And it's not going to be as simple as just dividing both sides by log. That doesn't work. And so what we need to do is, let's go back to our definition of a log. So going back where we had log, we're talking about base 10 x is equal to y. What that's saying is 10 to the power of okay, so our 10 to the y is equal to our x. So if this point here, substituting, so y is equal to this, what that means is that by association, 10 to log of x is going to be equal to x. Okay, and so that helps. So if you raise log of 10, as the exponent over 10, it's going to give us this value here. So we can do that here. So first we can do is get rid of the negative, so negative 0.5 is equal to log of H+. But then what we need to do is to fully isolate H+, is take 10 to the log of H+, will give us H+. So we'll take that side, 10 to log of H+. And what we do to one side, we need to do the other. So on this side, 10 to the negative 0.5. Okay, and so in doing that, our H+ concentration is going to be equal to 10 to the negative 0.5. And so this is always going to hold true. So another equation we can get from this, 0.5 was our pH, so negative 0.5 is our negative pH. Our H+ concentration is always going to be equal to 10 to the negative pH. Okay, and if we're talking about our OH minus concentration, as you can imagine, the OH minus concentration is going to be 10 to the negative pOH. Okay, and so that's going to help as well. So kind of in review here, some of the equations we have to work with. So for pH, that's going to be equal to negative log concentration H+, pOH, negative log concentration OH minus, Kw is equal to H+ times OH minus, which Kw is also 1 times 10 to the negative 14th. We've seen pH plus pOH is equal to 14. We've seen that H+ concentration is 10 to the negative pH, and that OH minus is going to be 10 to the negative pOH. Okay, and so that can help us figure some things out. The next thing I want to talk about real quick is going to be difference between a strong acid and a weak acid. Okay, and we'll start that up in the next video.